Number of tornadoes follows Poisson with mean 3. Find the variance of the number of tornadoes in a year given that at least one tornado occurs. So let x be the annual number of tornadoes. We have to find variance of x given x is greater than or equal to 1, given at least one occurs. So for this, we will need the corresponding probability function f of x given x greater than or equal to 1. Now we know that for Poisson, f of x equals mean power x, e power negative mean divided by x factorial, and here mean is 3. And x is equal to 0, 1, 2, and so on in Poisson. Now we need f of x given x is greater than or equal to 1, so that'd be equal to probability x equals x and x greater than or equal to 1 divided by probability x greater than or equal to 1. So probability x is equal to x is just f of x, and the fact that x is greater than or equal to 1 is taken care of here. So instead of starting from 0, 1, 2, now we start from 1, 2, 3, and so on, because greater than or equal to 1. And in the denominator, x greater than or equal to 1 means 1 minus x less than 1. And in this case, less than 1 only means 0. So 1 minus f0. And f0 comes out to be e to the negative 3, because 3 power 0, 0 factorial are both 1, just e power negative 3. So 1 minus e power negative 3, and then this is just f of x, but now we are going from 1, 2, 3, and so on. So expected value of x, so since we eventually, the variance of x given x greater than or equal to 1, so we'll find the corresponding expected value of the x and the x squared given x is greater than or equal to 1. So e of x given x greater than or equal to 1 will be the summation of x against this corresponding probability function, x times f of x given x greater than or equal to 1. And x times, and now this f of x given x greater than or equal to 1 we found here, it's 1 over e to the negative 3 times this, and we're also having it times x, so we just I've just timed this expression with x to get that. And now this summation starts from 1 because this one is starting from 1, and this is what we are substituting here. However, we would like it to start from 0 because we want to recognize it as an expected value of x. Now, in order to start in from 0, you have to throw in the term x equal to 0, because normally the summation is starting from 1. And if you throw in the term x equal to 0 in order to start from 0, now you see for x equal to 0, this whole expression is 0 because of this x. And therefore, even if we start the summation from 0, we haven't changed anything because all we have done is we've added on a term which was actually 0. So now we are in a good position because summation starts from our familiar x equals 0 to infinity. And now 1 over 1 minus e to the negative 3 is a constant which can be pulled out, and you're left with x times 3 to the x e negative 3 over x factorial. And now this 3x e to the negative 3 over x factorial is just f of x. And now we are doing x f of x, which we know is the expected value of x, because now when you take the summation of x f of x over all the possible values of the variable x, which are actually 0, 1, 2, and so on, then you get e of x. And e of x is just the mean of the Poisson, which is 3. So I've substituted 3 here. So we got e of x given x greater than or equal to 1. So now we will need e of x squared given x greater than or equal to 1. So that's summation of x squared against the corresponding probability function. And we found this probability function to be 3x e negative 3 over all this previously. And once again, this summation starts from 1 because this probability function starts from 1. but we want to start it from 0, which we again can without changing anything, because for x equal to 0, again this expression is 0 because of this x square, and therefore we get this one starting from 0, and then we pull the constant out as before, and then what's left inside is just x squared times f of x, and from 0 to infinity, and this means that this whole thing is e of x squared. And now to find e of x squared, e of x, when we reach this step in the finding the expected value, we had e of x here, which we knew to be 3, but e of x squared is not directly known, but what we know is that the variance of Poisson equals mean, so we use our famous formula that variance is equal to e of x squared minus ex whole square in order to get e of x squared, which from this equation will be variance of x plus e of x whole square. So variance is 3 because the mean is 3, and then e of x squared is 3 squared, that's 12. So we just substitute 12 here in order to get e of x squared given x greater than or equal to 1. So 12 over 1 minus e to the negative 3. And now we're in the position to find the variance of x given x greater than or equal to 1. That's e of x squared given x greater than or equal to 1 minus e of x given x greater than or equal to 1 whole square. Substitute the values, and that comes out to be 2.66, which is choice C.